And thank you. It's great to be back here in Perth. I think the last time I was here was in the before times, so it's been a little while now. Although that year, through bad planning on my part, I actually made the flight from the US to here twice in 2 months. I should have just stayed. Anyway, so introducing myself just a little bit. We have no clicker. There we go. So you probably know me best as a developer, an architect, and an author. Prior to the airline-related company called Sabre, which is allowed to say, I worked for a consultancy in the US called Cognitect, who were the stewards of the language closure and the database Datomic, and they got bought. I successfully managed to avoid the acquisition and then the subsequent IPO of their acquirer, and I came back after that. So I now work for Nubank, which is a Latin American bank. We operate in 3 countries, Brazil, Mexico, Colombia. We have 85-ish million customers across those locations. 1 out of every 2 Brazilian adults holds a Nubank account. We do credit cards, deposit accounts, and we've been branching out into lending, securities, investments, even a very small crypto unit. So as I was talking with my former colleagues about joining Nubank, they said, well, we have 3 Nygard-shaped problems. And they started to describe them to me. And I picked up one that was sort of interesting, but took me into a new realm. So reintroducing myself, I'm now in the data world. I'm general manager of the data business unit. And you might say, well, what is a business unit for data? I'm part of the global platforms building block, we call it. And my group is responsible for the environments that process the analytical data. And if you haven't gotten into this realm before, operational data is what all the microservices use. So when you're interacting, you're using your card, you're using your account, you're interacting with the operational world. But then there's that part that everybody doesn't think about during the design and gets neglected until you've already launched something. And then people go, oh, we need to feed the ETL. And the first time you encounter this, you're like, what the heck is ETL? ETL is the thing that gets a copy of your supposedly private database and then runs it through all the batch machinery to produce reports to keep regulators satisfied that you're a viable business and you're managing risk appropriately and you're handling your customers correctly. So we have our operational world with the microservices. We have about 3,500 of them in 20-some Kubernetes clusters, large numbers of Datomic databases, large numbers of DynamoDB tables. Actually, we're exploring the upper limits of how many DynamoDB tables you can have in a single AWS account. Catch me at the break if this is of interest to you. But then we have this entire other world. It's like a shadow world of the analytics and the ETL. It's very batch driven. We kick off a batch at 11 p.m. every night, and it actually, at this point, runs for about 3 to 4 days. We're ingesting petabytes of data every day, and we're producing petabytes of data every day in this network, or this topology that people frequently refer to as a DAG, a directed acyclic graph. And that DAG has 100,000 nodes in it. We run this on 15,000 EC2 instances. We're also probing how many Graviton instances Amazon has in each of its regions. We're starting to sort of see our own effect on the spot market when we're registering these instances. So we're doing a lot of heavy lifting, a lot of big stuff. But what I found interesting when I got into this was the sort of change dynamics that we've come to expect in the operational world are totally absent in the analytic world. So in the operational world, a work unit, a transaction is resident in your systems for microseconds or milliseconds. You can deploy something new in a few minutes. The lag from when you check something in to when it goes live is minutes. I mean, maybe a few hundred minutes, but it's still, minutes-ish. This didn't happen automatically. We did a lot of work over the last 10 years to get there. We were guided by things like the DORA metrics. We built platforms. We invented whole new technologies, like this whole observability tracing landscape. We spent 10 years coming up with new protocols and giant-sized systems so that we could get back to just having a stack trace when something goes wrong. So it didn't come automatically, but we got there. And then I'm in the data world, and a unit of work takes hours. So we have some jobs that run for 14 hours, and we'll get a spot instance revocation 12 hours in, and we have to restart. 12 hours all over again. It takes hours to deploy something because we've got 100,000 ops in this DAG, and we run tests. Actually, just running a build and doing a topological sort on the 100,000 nodes takes some time. So our builds are like 2 hours. From the time you commit something to the time you see the results is several days, because it's going to take hours to build, then you have to merge, then it runs that night, so you've got on average 12 hours delay, and then it takes multiple days to run. And so think about what happens to your appetite for change if you come in on a Monday morning and you make a one-line change, a one-line commit, and maybe you're going to see the results of it next Monday morning. Are you likely to go back and do things like refactoring and cleanup of old work that you did? Absolutely not. You're going to leave it. And that's what happened. People left it. So we're in this realm that's kind of the opposite of DevOps. Long lead time. My team was responsible for centralized operations, not only of the platform, but of all the executions of the jobs on the platform. Because it was so big, and the topology was complicated, and the semantics are difficult, you could make a very small change in an upstream data set, only to be called on the carpet by somebody 3 days later about why you've broken the regulatory reports. And you're like, I don't even know how I'm feeding those, because the lineage is complicated and somewhat opaque, and we've got query tools to help us understand the topologies, and the typical query returns several thousand rows. So you need specialized visualization tools to understand the topology of this data flow. People are afraid to touch anything. And because they're afraid to touch anything, they will disavow ownership of it as quickly as possible. Oh, that's the V3 process. I don't know anything about V3. I only deal with V4. As you would expect with these dynamics, we have some accumulated technical debt. We've had increasing costs because we're still running stuff we probably don't need to run, but nobody's willing to go in and take it out because maybe somebody uses it somewhere. So we also have a pretty high degree of frustration, both inside the team and with users of this environment. We also have this kind of chasm between these two worlds in the tech stack and the languages. So in the operational world, we happen to use Flutter, Clojure, the tiny amount of C#. But then over in the analytic world, frankly, it's dominated by Python. We have a lot of Scala and Spark for legacy reasons. But these groups don't talk to each other. They don't communicate. They don't use the same languages. They can't support each other's software. And to sort of put this into scale perspective, our code base is over 3.3 million lines of Scala code. And within that, there are multiple frameworks that users have written that dynamically generate more code and more data sets. Within that space, we're doing 60 pull requests a day. And you can probably do a little mental math. If it takes 2 hours to build something and we're doing 60 pull requests a day, we're clearly not lining those up and handling one at a time. So we've got this very complicated machinery for merge queues and batching pull requests together, testing the batch, and then merging the batch. So high cost, fragmentation, frustrated users, inconsistent results. Yeah, this was the problem I chose to pick up out of the three. The other two were worse. There is some hope on the horizon. And it turns out it's not just Nubank that has this problem. Most companies have spent the last 10 years or so evolving through a series of fads around big data, the Hadoop and HBase and HDFS era, through the Cloudera era, through data lake, and now a lot of us are kind of looking at this and saying, hang on, we're spending a lot of money accumulating all this data in the data lake, but it doesn't really seem to be adding a lot of business flexibility. Yeah, I mean, you can answer some interesting questions at points in time, and you can solve some optimization problems at points in time, but when your business needs to change and grow, like adding new geographies, multiple currencies, new products, that sort of thing, the data infrastructure starts to hold you back. And we look at this and we say, well, we've kind of seen this pattern before. We need a new paradigm around how we're dealing with data, where we allow teams to move at their own pace and do autonomous independent deployments with a platform that enables them to do this work without having to get us involved. And the platform can manage the cognitive load of the people who have to interact with it, partly by providing a high degree of discoverability and visibility. And I've sort of given away the punchline here, but it's actually not a very new paradigm. If you look at this coming from the software world, you say, well, that sounds like microservices. And the answer is yes. It's basically microservices for data, but of course it has to have a different name. Otherwise you couldn't brand anything or sell consulting services or whatever. So it's now called data mesh. And if you start hearing data mesh or you've been in data mesh, now you know the whole story and the motivation, right? It's about getting out from the inflexible, unpredictable, high-cost, high-friction environments. I have to give credit to Jean-Marc Degani, formerly from ThoughtWorks and now at a company called NextData, who published the book, literally wrote the book on data mesh. And I'm trying to promote this at every opportunity because data mesh is a term that is already in danger of being diluted into meaninglessness by people with things to sell. And often the things that they are selling are the same things they were selling a couple of years ago, except now it's got data mesh edition on the SKU. So data mesh as a paradigm rests on these key principles. Domain ownership of the data and the means of production of the data. Data itself is a product, and that seems sort of obvious at one level, but there's another level where it's pretty meaningful when you start applying product thinking to the data that you're creating. It does use a self-service platform, and this notion of federated governance. I'll get into each of these a little bit, but I want to start with ownership, because ownership and accountability and responsibility has been actually the harder part to accomplish. Building a self-service platform, like it's building software, it's not easy, but we kind of know how to do it. The thing about ownership is it's very hard to give somebody ownership unless they're ready to take ownership. And getting to that point has been an interesting challenge. So we needed to decentralize ownership. In the previous world, my team was responsible for the operations of the entire batch run. So overnight, if something goes wrong, my team gets notified, they get the Slack message, they have to get online, do the recovery and the incident report and all of that. And about 80% of the time, the thing that they were trying to fix was a change that a user had made in one of their data sets. And the problem would be reported by a consumer of one of those data sets. And so what we really had was the producer of the data set flowing to the consumer of the data set, and we're debugging it because something broke in that flow. Obviously, in order to debug that, we have to go and get people on the line, connect with them, wake somebody else up in the middle of the night. And really, we're just slowing things down by doing that. Most of the time, by the way, the fix was revert this particular pull request, build a hotfix jar, and rerun that job. Well, when we start decentralizing the ownership, we're encouraging not only the ability to change in that ownership, but also the accountability and the responsibility for the operation of that data. So we've done a very deliberate change program over the last year. We're not done yet, it's still going. First, we just had to map out the organization. What are the domains in the organization, and who's responsible for these domains, and how do the data sets map to those domains? This is all a kind of metadata that had not been captured in the system at any point, and so it was sort of a combination of like archaeology and sociology to find out who owns this data set, what's it for, what product is it affiliated with, product in the customer-facing sense, who's the management representative for that, and so on. Mapping all of that out went along with a communications program explaining to people why they should care about this and why it was important to them to produce a high-quality data product. Bringing product thinking to the data sometimes means, oh, yeah, these columns that I'm exposing, that requires the consumers to know way more about the internal definition of my systems than I really need them to know. And so maybe I'll add some new derived columns that are just a mapping so that this data is more easily consumable, becomes more valuable to the downstream. On a purely mechanical level, it also means we got a whole bunch of people to sign up for Ops Genie alerts and be the first responders when their data set breaks. You might be shocked to learn that once people had to respond to the alerts for their own data sets, actually the breakage went way down. Go figure. The other thing about creating this decentralized ownership, though, is that we also had to provide people the ability to create boundaries. When you're in a monolithic code base, anybody else's data is only like, one command space away. So you just do a search, you find a field on somebody else's data frame, you start referring to that, and our DAG has grown a new dependency, and you're now using somebody else's data that maybe they didn't mean to make public. But it's just the nature of the coding environments and the way things were packaged together and the fact it was all in one code base that you could very, very quickly proliferate dependencies. That was bad for you as a consumer because maybe you're getting intermediate data that's not fully finished, maybe it hasn't been filtered all the way, maybe it's not got great quality, but it's also bad for the provider of the data because now what might have been an internal field name in an operational system that was inadvertently exposed through the ETL, it's now a public commitment, and if you remove it, somebody else is going to scream at you, and you're going to get one of those Ops Genie alerts. So we have to provide the ability to create these boundaries and make good fences. What we're doing, and we're partway through this at Nubank, we're going through a series of stages to introduce the notion of public and private. So at first, private is just going to be a flag purely advisory, so that when you're consuming another data set, you can see that this is not meant for sharing. That doesn't do anything about the hundreds of thousands of dependencies that already exist, though. So there will be another step where we make it a warning at build time, and I fully expect there are going to be a lot of these warnings. But when that happens, when we turn that on, everyone's going to get notified that you depend on this list of private attributes. Enforcement is going to come later, perhaps much later. We're going to try an 80-20 approach where we say we need probably the worst offenders to take care of their stuff first. We're going to do that individually with assistance. We'll be the UN helping you mediate between provider and consumer to get to a good public interface. And then at some point there will be this tail where people are just not moving. It's sort of like an unfinished migration, or eventually you just turn the flag to enforcement after you warn them and warn them and warn them. Turn it to enforcement, and yep, now your build breaks because you're depending on something that was private. And we expect this process to take something like 9 months to get all the way from just having the ability to flag it to advising to enforcing. We're also going to make some other things private along the way, like the transformation itself. This requires us to split some things that in the data world generally are not split. When you look at most of the data processing systems, you'll see that it goes very rapidly to what's the file format in what kind of storage and what's the processing framework that's being used on it. So it's hoodie tables with Spark, and you're storing them in S3. It gets very concrete very quickly. The idea of ever even sort of separating the formats, the storage, and the transformation so they could be combined independently doesn't really happen. And if you're feeding data from a producer to a consumer, they're assumed to meet at the tables in the storage with more or less direct access to those tables. We're going to break it up so that a data product owner could say, this product is produced via Spark, this one's produced via Python runtimes, this one is produced via Abacus. The consumer doesn't need to know or care what the transformation engine is underneath that particular public data set. The things which are public, and we expect to remain public, are the ones you need to understand to consume and use one of these data products, the schema being the most obvious one. But there's also this question of lineage. When you are looking at a potential data product to use, you have to be able to understand and trust that data. Understanding you can get from schema and documentation and looking at samples and so on. Trust is harder. Trust sometimes means, where did you get this column from? Not what was the computation engine that produced it, but what were the inputs? How far upstream can I trace that to understand, am I getting what I think I'm getting? And this sounds maybe a little abstract or maybe a little paranoid until you start asking around your company to find out how many definitions of an entity like customer ID do you have. Turns out most companies have many different sets of customer IDs represented in different ways, meaning different things with different life cycles. Actually, if you practice domain-driven design, that's kind of a feature of domain-driven design, that you may have the same term in multiple places. So when you're consuming a data product, you need to know, where did this come from? The notion of output ports is like, how do I physically get access to the data that your product is producing? In most cases, this is going to be static files on some blob storage. Very occasionally, it will be a live database that you can query. And we're currently looking at how we could perhaps merge static batched outputs with streaming updates. Maybe those can be abstracted over, maybe they can't. Jury's still out. In terms of trusting the data, this is where the SLOs and the performance against those SLOs and the quality rules also come in. So if you're looking at a data product that says it lands by 7 a.m. every day, but like Delta Airlines, it only does that 10% of the time, and the other 90% of the time you're actually late, then you know not to trust it, or at least not to trust it for something that has to deliver shortly after 7 a.m. The quality rules are assertions that the producer makes about how the attributes relate to each other and what's allowed in those attributes. You can think of not null as one of the most basic quality rules. But there are also quality rules about distributions. So this should be centrally distributed, this should be left skewed. We should never see anything that's 1,000 times greater than the median value, that sort of thing. These are also quality rules you might enforce. An interesting thing about quality rules is the producer and the consumer of a data product might have very different expectations about the quality and baked in assumptions about what those quality rules are. So we're also looking at how you can give the consumer its own set of quality rules to say, in order for me to use the input, it has to conform to this. So all of this sounds great. Sounds like it solves the problem. Sounds like it'll help us break it all up. But obviously, it's not that easy to implement. There are a number of barriers in the way, both internal and external. Some of them are technical challenges. A lot of this requires software that doesn't exist. It requires protocols that don't yet exist. It requires generalization over vendor products where the vendors really don't want to be generalized over. But it also brings organizational change. And if you've ever embarked on a change management program, you'll know that the org change can be the hardest part of this. One of the biggest aspects of the organizational change is why should the data owners care about creating great data products? For most of these internal teams, the data is sort of a waste product, or it's an exhaust created by their actual process. It's not something that they think of as a resource that they're creating for anyone else's use. And in fact, if you look at what it means, what this data mesh paradigm gives you as an owner and as a consumer, it starts to look a little asymmetric. So as a data owner, I get flexibility to change the internals of my data definition as long as I keep the contract the same. And I get some predictability about the changes I make inside my product because I know that nobody else is depending on the internals. The consumer gets discoverability, trust, understanding. They get to consume the best data possible to create their data products. But the data owner also picks up the cost of support, which might mean responding to those Ops Genie alerts in the middle of the night. They get the cost of production too. So those 15,000 EC2 nodes that we're running every night, we do tag them according to consumption by the data domains. So we know who's spending how much of that compute time. And we're allocating that back to the business units that are driving it. Actually, that's also something we just started in the last year. And somehow, surprisingly, once we started allocating the cost back to the ones that generate the cost, instead of just having it on the platform budget, the cost started to level out and even come down. I don't know, a little mysterious. So we have to figure out, why, what incentive is there to actually be a data product owner and to provide your data to anyone else? I'll come back to that. I'm going to leave it as a dangling thread. In terms of the data product itself, this is actually one of the simpler parts of data mesh. The data product is the quantum of sharing. It's meant to be a whole unit. It's got some conceptual integrity. It's got some value in and of itself. It's got to be self-describing. It needs to be discoverable. It needs to be understandable. This part, actually, I think, is better understood than the rest of the data mesh. We've got the processing frameworks to create these. We've got ways of describing schema and documenting things. The platform is different than data platforms have been to date. So similar to the way that dev platforms have evolved, when we started with the DevOps idea, it was like, awesome, we're in the cloud, every developer can run EC2 commands to spin up their instances and deploy things onto them. And we pretty quickly discovered that the cognitive load of having every dev team doing all of that was high. And so we said, well, okay, we like DevOps, but not that much ops. We want to carve off some of that ops and have somebody else do it. And so we started building these dev platforms where, the platform provider gives you the tools, the visibility, the flexibility, but you're working at a little bit of a higher level. Very similar thing here with the self-service data platform. We want to provide ways to execute the work, make the changes happen, make the simple things easy. We want to provide some amount of flexibility in the transformation engines, in the storage engines, and so on, so that you can optimize your data product. But we also want to provide some automated guardrails to help you keep from hurting yourself. And this is one of those tricky things with any kind of platform. It's like, how much do you prevent them from hurting themselves, and how much do you let them have all of the power needed? So we're adjusting that dial. It's not a binary, it's not a switch to flip, but we're adjusting the dial to give more flexibility and more power, but we're also trying to provide advance warning. Like, okay, you can do that, here's the effect it's going to cause. You're going to land 6 hours later. You're going to consume another 10,000 hours of EC2 time. In this way, we think we're giving people the ability to make intelligent, local, optimized decisions rather than having the platform try to impose a one-size-fits-all. This also aims to help manage some of the cognitive load so that If you don't need to optimize all of these things, you get the sort of happy path or the simple version of this. I keep talking to my team about my fantasy that someday we'll have a GUI where business analysts can type in a SQL query, interact with it, look at the results, maybe visualize it a bit, and then click a button that says, turn this into a data product. And you get a data product with sort of all the sensible defaults baked in, and you can adjust them later as needed. All of this goes in the platform. A very key difference for us is that data groups have usually created platforms optimized for their own needs, not for the needs of their users. And so the goal here is that we need to be user-centric. That'll be automatable, it'll be CI-friendly, it'll be API-driven in some places, CLI-driven in others. And it will support variation because the users need that. Not everybody is going to write in Scala. It turns out it's a lot easier to find business analysts who know SQL and a lot easier to find machine learning engineers who know Python. So we need to meet the users where they are instead of requiring them to come to us. Now, in supporting the data owner, we have to do more than just give them the ability to run their transformations. We also have to give them the observability so that they can know what's going on. And when something breaks, they have the ability to go and figure it out for themselves. There's a whole area around PII discovery and classification where the tooling has gotten pretty good. It's an important thing for the company overall, but honestly, no data owner really ever wants to go in and label all their columns. So we'll give them some tooling to help them do that. Automation with guardrails. Similarly, for data quality, we're bringing in some standard tooling so that not everybody has to figure out how to run sanity checks all over their data. We'll just give them the ability to make some simple declarative assertions about the nature of a column or relationships among columns. There's this broad area that we're generally referring to as change management. It's not a good name. I'm hoping to find a better one. But this means when I'm about to commit a change, advise me if it's going to hurt me. So you can think of unit tests in an application as a basic form of change management. I'm about to try to do this change, and it's breaking a bunch of things. There are other dimensions that we would like to use here. Unit tests don't work that well on data transformations. It depends too much on the actual data. So we're working on ways to predict, am I making a change that has significantly delayed my outputs? Am I making a change that is significantly increasing my costs or harming my quality? The platform also needs to support the data consumer with the ability to discover, trust, understand, and use the data products that are available, which means that even though people are deploying and delivering their data products independently all the time on their own schedules, we still have to have some place where you can go and say, what's out there? What have people provided? How many versions of customer ID do I really have? And that's going to be in the platform as well. I mentioned the incentives earlier, and why should I ever be a data product owner? Why would I want to do that and sign up for it? And the answer is that the platform is going to help on this by creating a kind of marketplace where you can set a price on your data. Hopefully the price is more than it costs to compute and supply. And consumers of your data will be paying that price via an internal transfer pricing mechanism. This is the kind of stuff that absolutely bored me to tears until I was responsible for the platform group in the middle of all of this. But transfer pricing is a pretty well understood way of setting up incentives inside a company. So if you want somebody to do less of something, allocate the costs back to them. If you want them to do more of something, allocate someone else's budget to them for doing it. And that's the incentive we're going to try and set up for the data product owners. This part's a little bit speculative, a little bit in the future. It turns out our internal accounting systems aren't that happy with getting 500,000 transaction rows per day that say send 5 cents from this account to that account. So we have to figure out some ways of making that a little more palatable. As an industry, I think we have some missing pieces for this whole data mesh story. If you read Degani's book, there's this fabulous table partway through. After she's outlined, what is it, what are the pillars of it, It's how do I build it? And a great table of these are the components you need and the status of it. And like 2 or 3 of the rows say there is some open source thing that does this. Everything else, the whole table, it's proprietary, proprietary, proprietary. Built as a one-off for this client, built as a one-off for that client, built as a one-off for that client. What we lack in this world is interoperability across these vendor islands. So there are a few big vendors that everybody is dealing with. Snowflake is one of the biggest. In fact, they're so prevalent that there are now consultancies that aim to help you optimize your Snowflake bill. Just like there are consultancies about optimizing your AWS spend. Databricks is another giant in this arena, and they have zero incentive for interoperability between each other. I think if this is going to happen, it's going to have to come from the consumers of these platforms, or the companies that provide internal platforms using these external vendors, or it's going to have to come from the open source community. In the microservices world, Swagger was actually a huge step forward because it provided a way of describing the metadata around a service that was good enough and commonly used enough that it could become kind of the meeting point for tooling providers and system vendors and software creators. We don't have that in the data world. So there is no Swagger, there is no open definition for what a data product even looks like. If you were to say, write down the definition of a data product, you'll get a lot of hand waving. The platforms that we work with today are really not that API driven or integratable. They all meet at the files. And so the idea of interposing a kind of a programmatic layer that says, I'd like access to your file and I'd like it in, a Postgres dump file. That doesn't really exist. So there's no notion of like content negotiation. If you are consuming 10 different data products that are each outputting in their own storage format, you need to include the adapters for all of those storage formats, and you need to include the APIs that are able to speak to all of those storage formats. This is a lot of complexity, and it's sort of, it creates a sufficient barrier that most people would rather just glom everything together and pick a single, monoculture provider, which just leads you back to the monolithic world that DevOps forgot. I'll also say the vendors that are out there talking data mesh today, I've looked at most of their products and they don't look very much like actual data mesh. They look a lot like, vendors trying to pick up on an early buzzword and use it to sell something. But they will not create the outcomes that I'm looking for from data mesh, of teams moving at their own pace, deploying autonomously with a discoverable, federated world of data. Well, I've talked about where we were at Nubank when I joined a year ago and where we're going, but like any big change, there's always the question of how do you get there? And the answer, as always, is incrementally. You make a small change in several places, and then you go back and you make another small change in several places, and so on. And in our case, we're looking at a number of distinct, what I'm calling architecture increments, that also go along with cultural changes, observability changes, responsibility changes. So getting to the point where we can use more than just Spark is one of them. Getting to the point where we can publish information to catalogs is another. Catalogs here is plural because it turns out, just like you've got multiple customer IDs, you've probably got multiple data catalogs, and they don't all look the same or contain the same metadata. So we're going through these architecture increments one at a time, but we're also doing a very widespread change management process. That always begins with explaining why are we doing this. The truth is, most people in most of the business units don't really care about the data. There are a handful of consumers that really want excellent data. The regulatory affairs group, compliance, some of our risk management teams, our credit modeling teams, they all need great data, but there are a lot of intermediaries that don't even think about it on a daily basis. So we have to explain, why does this matter to the company, and why does this matter to you? Communicating relentlessly is vital, and when you're sick of saying something, people are just beginning to hear it. And if you stop repeating it at the point where you're sick of saying it, they're going to assume that it just died off and went away, that it was something that fizzled. So you have to keep saying it over and over and over again. In my case, I've found ways to speak to the executives on a regular basis. I've got product managers speaking to product managers on a regular basis. I've got engineers speaking to engineers on a regular basis. I've got town halls. I've got broadcast events. So many, many different channels for communicating where we're going and why. You've heard me talk about incentives and feedback loops and the magic of getting the right feedback loops in place. It's impossible to overstate the impact of incentives. If you've got business units or teams whose incentives are opposed to data mesh, it will not happen. This is a place where getting into the planning cycle, if you use OKRs, when are the OKRs defined? If you use annual plans, when are the annual plans written? Getting integrated with that so that you're not showing up just after somebody's finished their quarterly plan and saying, hey, by the way, at the end of next month, I need you to stop using all of the private data sets upstream. Once all the capacity is allocated, you're asking for change. Better to be there at the beginning and get it integrated right away. And people often ask, do you do this from the top down or the bottom up? And the answer is, you go top down, bottom up, middle out, inside or outside in, inside out. You have to build the support everywhere possible, and you have to keep continuous efforts to maintain and sustain that support. So show people that they made a good decision by supporting you before, and that decision is paying off, so that they have reason to continue supporting it now. Then each increment that we're delivering involves a technical capability, some governance change, and this means a change in responsibilities, new powers for people so that they individually get something out of it, and then a lot of follow through on delivering it and follow up. And what I mean by follow through and follow up, suppose you come to somebody and say, hey, we're going to need you to move all of your computation files from this subdirectory to a new project structure so that we can eventually move it out. And they're like, okay, we'll go ahead and schedule that. And then you say, oh, but we're not ready just yet. We actually need you to do this in 6 weeks. You're like, why'd you come talk to me now? So you continue following through and saying, this is a thing we're going to need you to do. This is when the earliest date you'll be able to do it. This is the latest date we need you to do it by. And then you track it and see where they are and report on it. I'll also say you need internal support within your own team to do this. In my case, this means the entire data business unit that's been kind of under fire and on the hook for delivering all of this for the past 7 years or so. One of the keys is make sure there's room for everybody to come along on the journey. It's very often the case when you've got a legacy system and the shiny new thing that a team gets stood up to do the new thing and some part of the team is left behind. Well, the part of the team that's left behind isn't just going to, feel bad and resent it. They may actually have reasons to impede the movement. And, hopefully the way they do that is by suddenly making the legacy thing a lot better and putting the new thing on a treadmill to catch up to parity. But maybe that's not always going to be the case. So make sure there's room for everybody to come along. Don't create legacy land and promised land. As you're making these changes and doing the architecture increments, don't forget to do architecture increments that benefit your own team, reducing the operational toil or the keep the lights on kind of work, giving them new capabilities, or even just giving them time to fix some of the things that have irritated them for a while, but they've been under the gun. So make sure you've got that. And definitely Don't schedule so that everything is full up to capacity all the time. Leave some slack. Tom DeMarco said that change happens in the white space. People can't try something new if they're under the gun to deliver at maximum capacity all the time. So you got to leave some slack. So wrapping it all up, data mesh is a pretty promising paradigm. I think you're going to hear a lot more about it over the coming years. It does have many of the same characteristics of service mesh and microservices. It does allow us to decentralize the production and consumption, although you still support it with a centralized platform, and that platform needs to be oriented differently than before. Very much customer-oriented rather than implementer-oriented. Governance in the data world is definitely going to be a thing, probably much more of a thing than it is with microservices in the operational world. But we need to federate it through tooling so that you don't become a bottleneck or set yourself up as a bottleneck. And then finally, be very wary of vendor capture. There's a lot of money at stake. There's a lot of investment, a lot of VC. The landscape of vendors in this space is an eye chart. It's got thousands and thousands of companies on it, and many of them are running out of money and being consolidated. So it's a point in time where the vendors have very high motivation to get you on board, but not necessarily motivation to get you the kind of decentralized, federated governance, independent operation that I'm talking about here. So this has been kind of the year one experience report from my journey into this world that DevOps forgot and that I haven't been in before. I hope to come back in future years and tell you how it went, what worked and what didn't. And of course, I'm interested in discussing this with any of you at any of the breaks. Thank you.